Oh, right. I gotta do that, don't I? Okay, chat. We're back.
Back. I know it's been a while.
After a hiatus.
Been a while.
Okay. We're gonna fix what Seifu broke. That's gonna be the first thing we work on. We're gonna talk about that, buddy. We're gonna talk about that.
I don't break anything. What do you mean?
It's okay. Everyone makes mistakes.
Oh, you want to talk about breaking things?
Oh, whoa.
We can talk about that.
Whoa, buddy. Whoa, dude. Come on, man. Come on, chill.
Gotta maintain appearances for your chat.
Yeah, pretty much. Hold on. Where in the hell is? Where's the? Oh, wait. Is that it? Here we go. Okay. Okay. So what are we doing with this piece manager here? What's the goal?
My brain's kind of foggy right now, but
I can tell.
In a nutshell, all the with output stream functions is supposed to replace this piece manager, but the problem is it doesn't really work the way we want it to. Yeah, this just doesn't work the way we want it to, and I have an idea to fix it. Because the reason why this doesn't work the way we want it to is because can't really explain it. Can't really explain it because my brain's too foggy. But I've already been through this mental process, and the key reason why we can't do this is because you either need to set this to a broadcaster. This needs to be a broadcast instead of an MPSC, or we need to create a trait for this and just implement off the trait.
Okay.
That is the only way to do this.
Let me just.
I can't tell you why right now, but my brain has already been through this road, and that is the only way to do this.
Okay.
So, yeah.
Why? Hold on. Let me read my my issue again so I can refresh myself. Okay, it's gonna likely be done sequentially. Oh wait, did I find my music? There we go. Okay, good. You request PC or pure actor A, B, and C. It shouldn't be an issue here. If you're implementing this, the process should start. If we are choked, okay, that's fine. How do we know when to start this process? Okay. If we detect if a piece has not been received. Okay, so why do we even need like a separate piece manager? Why can't we just?
Because normally this stuff is ran on a separate thread, so it doesn't block the torrenting process. Because writing to the disk takes time, especially if someone's on a hard drive. It can take a long time depending on the piece size. So we don't want to block the torrent instance's queue while we wait for that.
Okay. So
because I found out that the queue is only 32 messages. So we can only have 32 messages. We can only have 32 messages at a time.
For what?
The torrent instance. What do you say?
For the torrent instance?
For everything, for everything. Every actor has a max capacity of 32 messages.
Okay.
At a time.
Yeah, that's a little bit of an issue.
Yeah. So I'm trying to. So because of that, I don't want to clog that up. So that means the more time you take to process message, the more likely we're gonna have a mailbox overflow.
Yeah, and then that's just
Yeah. So having the piece manager like inside the actor itself, not running on the same thread, this isn't a very good idea because it doesn't really need data from the torrent instance itself, from the torrent actor itself, and it will just hold up the queue for longer than we have to, especially if they're on a hard drive, because that's gonna take a while to write. So,
okay, that seems fair. So hold on, let me share my screen real quick. Okay, so what you're suggesting is, hold on, can I just share my entire screen, please? Come on, Discord. There. Oh my god. Okay. So what you're suggesting is basically, so right now we have our torrent instance, and we have we have some peers, and we have some trackers. What you're suggesting is we have kind of a piece manager actor that requests the pieces from the peers.
No. So the piece manager would solely be for writing to disk.
Oh, okay. So, but the
So
requesting
it's
would still be
handling.
done from
Yes.
torrent.
Yes.
Okay.
So that's yes. So the requesting will still be done from torrent. All that would be happening is from the piece manager is it would be what's managing putting the files together. So once we receive the piece and we verified it already, that's when the piece manager comes in.
Okay. Okay. I mean, that seems
So yeah.
fine. Okay. So let me.
And where the user bypasses with the with output stream, so that's where they just cut off that whole process, and we don't need the piece manager anymore because they're handling that themselves.
Mm-hmm. Okay.
So the reason why the current way we're doing this, or I was trying to do this, doesn't work is because there's no way to. It's like a logic order problem here where we can't clone the receiver,
Mm-hmm.
and we can't initialize it. Like I can't really explain it. Like I can't really explain it right now, but it just doesn't work.
Okay. So wait.
Doesn't work.
Hold on. What is the receiver supposed to do here?
It just receives the streamed piece.
Oh. Okay. Oh. Right. My bad.
Yeah.
Okay. So we. Wait. Do we even use receiver anywhere? Hold on. There we go. We do it there. Okay. So process piece and we self.receiver.receive.wait. And while we do this, then we append to it.
So yeah, this code looks fine. I haven't tested it, but it should do what it's supposed to do.
Yeah, there might be some.
That's not.
I'm not sure about the
It's
open
not-
options. I don't think you need to directly use open options, but that's fine. That's fine. It doesn't matter. We can worry about that later.
We need to like refactor this into a trait.
Trait for peer actors or trait for torrents?
No, it's a trait for the piece manager. Should be a trait, and then we should implement file. We should implement a default for that trait. So our own implementation of piece manager would be the file manager, and then output stream instead would be like set piece manager, which would just take anything that implements piece manager.
Okay,
Make sense?
I mean, that kind of makes sense. Okay, so
Which would be better here because it means that we won't have to clone the receiver and we can just pass it in.
yeah,
That'll be fine.
yeah.
And you can just keep sending messages. It'll be a lot easier to do it that way. And I think it'd make more sense.
Yeah.
So I think we change this.
Okay.
Okay. So I'm probably just gonna delete all this.
Okay.
Don't worry, it's in source control. If we need to get back to it, like we can.
Oh, that's fine. That's fine.
So what we need to do is to have a trait piece manager.
Oh, yo, hold on.
So this actually looks pretty good.
Hold on. I actually I completely forgot to turn on my cat camera. Hold on.
And did you make sure to turn on music, by the way?
Yeah. Thank you.
Okay. Yeah.
Okay. I'm still listening. You can talk.
Okay. So this looks good. So it has get piece. Do you feel like any of this needs to be async? Yes, it does because you're going to be ranked the file system. So yes, it does.
Yeah.
So piece manager. So it doesn't need a get piece. Receive piece. Receive.
There we go. Okay.
And then bytes.
There we go. Okay, so let me hold on. Okay, so instead of
What other?
hold on. Okay, so instead of
So,
that,
no, so this would be publicly. This should be publicly accessible to the user, by the way.
yeah.
Yeah.
Okay. So I'm just still trying to grasp what we're planning on doing here. Okay.
Okay.
So
This is
when
fine,
we
so we can do this.
when we receive a piece, we're gonna send it to that receiver, and that receiver is gonna process it on a separate Tokio thread.
Yes.
So concurrently.
Well, yes. I'm trying to. Well, now that you're saying that, I'm thinking we should. Okay. Here's what I'm thinking.
Mm-hmm.
'Cause this shouldn't do this. What we need this to do, we need to be able to run this in a loop without it consuming mute self. Does it need mute self? What would it need?
I can't think of a reason why it would need to mutate self. Because all it needs to do is write
If
this
it
to
doesn't-
disk. It needs to update the bit field, but that's atomic. Or our bit field.
Well, no, we'll update the bit field the moment we received the
Oh,
piece.
right. Well, once we verify it.
We don't need to do that.
But yeah.
But yeah, we'll verify it too. This doesn't handle that.
No,
This is handling is just what we're doing with the bytes after we have verified and all.
Yeah.
That's all this is handling.
Look up current file writing Rust. Let me see if this is here. Okay. Look and see what else I got here. Yeah, okay, that's not super helpful because I want to make sure that we're not shooting ourselves in the foot here. Okay, so hold on. Okay, so you're saying that we want. Hold on. I got this. Come on, brain. Come on. Okay, so what do you want to implement this trait on again? Uh-oh. Yeah, I think he's dead, chat. Safe. You there?
Oh, my mic is muted.
Oh,
I didn't know.
Okay.
Okay, yeah. Yeah, so this trait is going to be publicly accessible to the end developer. But we're going to implement using this trait a file piece manager. So that means it'll automatically piece together the file on disk. And that's what this is for. So this will, yeah, that's what this does.
Okay. And we're just gonna run this in a separate thread, so we can.
Yeah.
But we can't write multiple pieces at the same time, can we? We can write one piece separately.
Well.
Yeah, that's what I'm not sure about, cause.
Oh no. We can actually. I think we can because the thing is the engine, it handles everything one at a time. So it wouldn't receive the next piece until after the current message is already finished being handled, because it handles everything one at a time. The torrent instance handles everything one at a time. So we don't really have those conditions. That's why every message is able to have mute self, because it handles everything in order.
Yeah.
That makes sense.
Okay.
I don't think we'll run into that issue.
Yeah, no, I see what you're saying. Okay, let me think about that.
And then I think I can make this force implement clone, then sync. That works. Okay.
I think. Do you need to implement clone if you have send and sync?
For sure. Well, if it works, it works. It's fine. Struct file manager. Okay. And then just have this. Just make this public. It's fine.
I don't think we need other than
whatever. I'll just do it like this, and then
should be fine.
async.
Drive clone on.
Piece.
That's it. That's kind of doing this down here already. The same thing
What
down
did you
here. You're rewriting what I've already done.
Oh, I didn't even see that. I
No,
didn't
you're
see
good.
that. Oops.
Yeah. Okay. There you go.
Okay. So now this will run every time we receive that data.
Mm.
And then what we can do, we need more than just the index, I'm pretty sure, no? We need to know what file to write it to. So we need to know what file this piece belongs to.
Yeah.
And also we need the offset too. So we need the offset 64. Oh, just set this to U size.
Do we want to just go ahead and use just maintain the actual file that we're downloading here in the struct, or are we gonna have multiple files? I'm still a little bit confused.
What do you mean?
Well, yeah, okay, no, because okay, are we handling multiple files with a single file piece manager struct?
Yeah, all this does, like all this will do is you send bytes to it and tell it what file it goes to, and it's just writes it to disk. That's all this is responsible for.
How do we know what file it goes to? We're gonna need that file object.
That's gonna be handled in the engine, in the torrent instance.
Huh?
We already talked about the calculations for this in the milestone.
Yeah,
Figuring out what piece goes to what file.
Right, but how?
Index.
But how are we getting the file object into the receive function?
We don't need the file object. All we need is just the file name. That's all we need.
Okay, but how are we getting to that specific location where this temporary bytes or buffer, whatever you want to call it,
What do you mean?
is stored on disk? Right, because right now we don't know where this file starts, and if receive only handles one piece, and we call receive multiple times.
Yeah, we have the index and the offset. That's for.
Right, but we don't.
And calculate where this piece goes based with the index and offset.
No,
what do you mean?
No, because we have nothing. We don't have this, so how do we know where the file actually starts?
Are you listening to a word I'm saying, Oscar?
No, I am.
Okay, so are you asking a word? Are you asking where do we put these bytes? Is that what you're asking?
Yes.
You received?
I'm aware that we have the offset and the index, but we don't have the start or end location of the file itself.
What do you mean the start and end location of the file itself?
Okay.
You mean?
Let me.
Okay.
Let me just share my screen. Okay. Here. I have it shared, right?
Yeah.
Okay. So if we have if this is the location, the memory on our disk. Let's say just each of these is a byte. Okay, let's say we have 3 files. We want to put one file here, right? We want to put another file here, and we want to put another file here. Actually, hold on, let me get like 2. Okay. Here, let me add like a
Are these
few
like
more.
representing pieces? Is that what I'm
We're
looking at?
we're gonna say that every tick is a piece. So like this would be one piece. This would be 2 pieces. Okay, so let me add some more pieces so it makes it like actually clear. Okay, so let's say okay, so no, okay, so let's say we have hold on. Okay, we want to write to file 1. This is file 1. If all we have is the index in the offset, how do we know where to start? in memory.
What do you mean where to start? You mean which piece to start with?
No, if we're given a piece and we know it's piece number 1 for file 1, how do we know to? Well, yeah, no, ice cold witch. That's the problem. But we don't have the file object. So if we have, hold on, let me move this up here. If this is file 1, okay, and we get piece 1, how do we know where to write to on disk if we don't have
We just use the file name. I put an argument for that if you look in the code.
Right, but yeah, right. So can we just create? Hold on. Let me look. Hold on. File.
You get the file name, all the file names from the infodict. You have the name of every file in the infodict.
Okay, so you're just saying that we just constantly reopen the file and create a new file struct?
We don't have to. Yeah, yes, we just constantly reopen the file, because why would we maintain that connection and maintain ownership over that file for now?
Hold on, let me read what someone's saying. So the file says we can know the file is on disk based on the file name given. We can actually know exactly the file. Well, yeah, but that's if we're having to constantly recreate that file struct, that can't be very efficient.
Wait. File open? File open and file create are two different things. What do you mean?
Yeah, no, I know open. I'd probably say create.
Opening I'm pretty sure it reserves that file to our process from the operating system, so no other threads can write to it.
Okay, so
which might not be what we want.
You're saying
I think it's fine to just do file to open.
We just file open file name every single time we want to write a piece?
Yep.
Okay, let me see. Okay, that feels extremely inefficient. Like that. Hold on.
What's the problem with it?
Let me just see. There's like efficiency.
Because the alternative is to store it in itself, which would
yeah, but like
make lifetimes basically impossible with Rust.
Yeah. Hold on. Let me.
And also, we would need a mutable reference to it. That's another thing. So we got to store that in arc mutex, and that's just more problems that we don't need. I don't really see the downside of it.
Yeah, no, and I worded my question poorly, but
and also let's say that also creates this problem, because if we have ownership of this file, because the operating system, once we open the file, this process has ownership, so we can't edit that file anywhere else. Let's say we're seeding back a piece while we're writing to that same file. We can't do that anymore.
Yeah.
Because our process, this thread owns that file completely. So we can no longer seed back using that same file.
Okay.
So we have like a 40 gigabyte piece. I mean, a 40 gigabyte file.
Yeah,
Let's say we have like half the pieces.
We can't reopen that same file.
Yeah, we just can't seed now.
Okay.
This one thread has ownership of it.
Okay.
File that open has that much overhead.
Okay, that is something I want to look at, because I feel like there is probably a way that we could get around that, but let me look. It just because if there isn't any overhead to that, if that's like if file open takes absolutely like no processing power, then I don't really care. We can just do that over and over again. But
and also, piece writing doesn't happen that often, because remember, receiving a piece can take a while.
No, won't it though? Because we can have up to 10,000 pieces in a torrent.
Yeah, you're right.
So, or again, I mean roughly. Attempts to open a file in read-only mode. Okay, so firstly, open only opens in read-only. I'm sure there is. Hold on. I'm sure there is like some other way. Hold on, open a file to write. I'm probably missing something. A file to write. No, so the problem with an in-memory buffer, Ice Cold Witch, is really, well, I mean, no, it's just the fact that we're gonna that we could be downloading multiple gigabytes at a time.
Well,
And there's no reason
no,
not
you
to
said
just
right chunks. You said right chunks. We can have like 60 kilobyte chunks or like 8 kilobyte chunks that we write in. But we're already just storing the whole right now. This current way we're doing this, we're already storing the whole piece in memory, just in this bytes right here. Because you see data bytes. This will just store the
that should
whole piece
be
in memory anyway.
that should just be a stream though, shouldn't it be? Because we can stream to disk, right?
Yeah, but that's complexity that we I don't really feel like adding right now.
Wasn't that something that you were like dying to do, like 3 days ago?
Yes.
And we have this
Yes.
stream piece, either struct or trait or type, whatever it is.
Yeah, but that's okay. So that would require us to redesign the way that we
Oh,
handle piece by piece.
right. My bad. I forgot that it's
Yeah, that would,
okay. Yes, yep. My bad.
So,
My bad.
yeah.
Yeah. Okay.
We kind of have to.
No, that's fine. That's fine. Okay. Hold on, let me just see.
Right now, we are kind of forced to use to store the whole piece of memory. We're already using 40 megs of RAM. So
Yeah. Oh, here. Better yet, we can just use. I think we can just use file system write. So I don't think we have to even like call open. As far as I know, I think like we literally just. Hold on. Let me Rust 1.26 and onwards. It should just be file system write to file. Actually, what are the arguments to that? I don't.
well, we're only gonna be writing specific bytes.
Yeah, that three
writing-
space indenter. Yeah.
Yes, 3-space indent is the superior way.
It really
we
is.
switched immediately.
No, he sold me on it. It really is nice. Yeah, okay. I don't know what function we would need to be using there to do that, because you're right, because we need to write to specific bytes. So maybe we do need to open it and then file.seek or whatever it is.
And also,
but-
we need to start creating on the file system. I believe we need to fill up the file with null bytes.
Yeah, that's.
We need to create each file on the file system and fill it up with null bytes.
Hold on. I asked someone in the Rust Discord about this a while ago. Hold on. From Oscar. Let me see. Why can't I find? Oh, maybe make some searching. There? No. I should just let me run my user. Oh my god. Life is so hard, man. No, I don't need to open search. Okay, hold on. Let me just look, because I did see a bunch about, or not see a bunch, but
Null bytes.
why can I not search in Discord anymore? Okay, thanks Discord. Average Discord moment, man. Let me just go to the. It's gonna make me crash out, dude. Maybe you get tier 1 crash out. Okay, Rust server. There we go. Right to various parts of there we go. There's my question. Okay, here we go. So this is maybe open options is the way to go. I don't know why. Okay.
Yeah, I thought so.
I guess. Let's see what the other answers were.
Let's see if we got the link to GitHub.
It should be linked in the description now.
Maybe Twitch?
Twitch? I don't really link anything on Twitch, because I have like no
Pin it
viewers.
in chat, bro.
What?
Gotta pin it in chat, bro.
Okay. Hold on, man. Hold on. Give me a second.
Yep. Just need to redo this whole piece manager thing.
Yeah. Here. Okay. Let me like pin. There we go. Okay. mainly unpinned or end of stream. Great. Mentions Corona. There. Let me look and see. Okay, yeah, here. So let me send you the thing that I got sent a while ago. So it should be this, and then let me size over here.
So what I'm from reading, there's ways to do this. There's 2 ways to do this. You could either let me see what you sent. To fill a file with null bytes.
Wait, that's not, hold on, that's not exactly what I'm thinking of though. Let me find.
Oh, well, we need to fill the files with null bytes before we do anything, otherwise the secret won't work.
No. That's what I need to look at.
I already know how to do it. There's 2 ways we can do this. Well, actually 3. So, we can either write. You can set the length of the file, which I don't think we can do that. Never mind. So we have 2 options.
Okay.
We can write the file in small chunks. So that means that we just like chunk up 8 kilobytes of zeros and just write it to the file, which is slow.
Yeah.
But it's the only way to do it in Windows. But in Linux and I think Mac OS, there's dev/null, and we can you can just have the operating system do that for us.
Okay.
So, do you know how targets work? You know how that works?
Target
macros in
nope,
Rust?
absolutely not.
So you can have OS specific code.
Oh, right. Okay, yes, okay, I think I know what you're talking about, maybe.
So do you see where I'm going with this? We can have an if check at compile time for Windows and Mac OS. I mean, Linux and Mac OS versus Windows.
Yeah.
Where on Linux and Mac OS, we can have /dev/null just fill up that file for us without it taking up any more of our memory, and go from there. And then on Windows, we can do it the old slow way and have a little bit more RAM. And if you're using Windows, you probably don't care about that anyway. So
yeah, hold on. Do you still map mic race? When I have time, yeah. But it's more of a hobby than like a sport now. Sorry, go ahead. Yeah. Okay, let me look.
Let me check.
Standard alloc, maybe. 'Cause I know I had. I know I looked at a thing for this at some point, but I forgot about it, or I didn't save it wherever I needed to save it. So, well, maybe I pinned it in DMs with you. Let me see. No, I didn't. Okay. Options. Open buffered. Block share. Wait, but buffered? No. Let me start file secret. Wow. File open. Link.
Yeah. So on all Unix-like systems /dev/0 will just be a never-ending stream of zeros, and you fill up the file like that.
Okay.
Without taking up any of our memory.
Okay, that's nice. Yeah. So okay. So what function are we using for that, or what trait or struct?
Hold on. I'm doing more research.
Oh, flashback. Thanks, MIT. See what else we got. So, file seekable, concurrent, blah blah blah. Maybe.
So there's ways we can do this. Okay, so the most efficient way is actually with Linux using libc,
Oh.
where it writes absolutely 0 bytes to memory.
Mm-hmm.
But we can add alternatives for Mac OS and any other system.
Is Mac? What file system does Mac run on?
No, Mac is Unix, like, so it has /dev/0.
Oh, okay, okay. That should be fine then.
It should work basically the same.
Yeah.
Windows another, and also,
yeah.
I mean, technically, there's nothing in our code that's stopping us from supporting like Android and Mac OS.
I mean, yeah, but
that's
that's not really a priority right now. And realistically, for sake of just getting this done, we can always just do Linux and Mac right now, and then do Windows later. Not that.
Well, right now, it wouldn't really be that hard to add Windows support. It'd just be less efficient, but it would probably be just like an extra like 20 lines of code.
Okay,
and it'd be fine.
That should be alright.
Okay, so we need to fix this. We need to fix the trait, and we need to have it in init.
Oh, hi, what? Huh?
We need to have like a pre-start. Okay, let's have it do that. Called pre-start, which in our case would create the file buffers. And this would be ran on the torrent start. So this would be this, and then also we need to change this to like include.
Oh, okay, okay. So okay.
Yeah.
Start self. So this would just make file buffers for all given files.
Yes.
Yeah.
And then so pre-start can be used for whatever people want. We could probably add a default function for this.
Yeah.
Empty.
And you want piece length and total length to be a U size, right?
Yeah.
Yeah.
Definitely.
U size. What is that about? I don't know.
Not mad. Why are you mad? Okay.
Is it just mad?
Just ignore that.
Okay, that's
Okay,
nice.
P-start. Okay, so this
Wonderful.
P-start should take in. I guess it could.
A vector.
Probably...
Wait, no.
No, because it needs the file name, so we could probably have it taken the info dict.
Yeah. And then just.
So...
hold on. We're gonna need this to handle multiple info dicts though. No. Oh, no, because we're gonna have one piece manager per torrent, right?
Yeah.
Or
exactly,
file piece manager. Yeah. Okay.
Yep.
Okay. Yeah. So this
that's fine.
Info.
Oh.
Info. And then that should be. Let's see. Okay, actually, let's see what the infrastructure has again, because I forget.
Honestly, I don't think we should have the new here. We should just let them handle that. Yeah, okay, I don't think we have the new in the trait. I don't think this is right.
Yeah, I was gonna say, like,
they should handle that. So
yeah.
So we start. Okay, so we have the info.
Wait, hold on. If we have multiple files, why do we have piece length and total length as singular fields?
Because they're constant. Piece length doesn't change per file, Oscar.
Right, but if we have multiple files, are we getting the total length?
Length is the total length of all the files combined.
How is that really useful for us, though?
My Copilot generated it, but I think it could be useful later on.
Oh my god.
No, shut up. Anyways, I guess in the piece manager function, you can also have a default for figuring out. You should have functions for Actually, we could just probably have. Yeah. Okay. So we can take the pre-start here, and then this is something that there's. Okay. So info dot. Well, it should be renamed to info dict, so it doesn't interfere with our info macro.
Yeah.
And then we have info dict. Piece counts.
Where? Info keys. Oh, right. We have a file with the info keys, and then I gotta look at an example of a multi-torrent file again. Here, let me just
Keys.
torrent file save.
Probably should add more functions to the info. Probably should add more functions to info. Because right now we don't have access to like a lot of the data inside of it.
Yeah. No,
probably is important.
No, you're right. Actually, I think the info, and then we have the files.
Like a lot of these fields should just be pub. Like a lot of these fields should just be pub.
Yeah, that's probably fair. Let's see the file, and then okay, so you should have that. So, what's the? Okay, so okay. I'm understanding this now. Are the info keys? Are those used for everything? Hold on.
What do you mean?
No, okay, sorry. If we have a single file torrent, are the info keys still used? I would say yes, right? Yeah. Okay.
See the enum.
No, yeah. I'm looking at that and the in the Ben code spec, or not spec, but just in a decoded torrent file. But other thing, how do we tell which pieces belong to which?
What did you say?
Because hold on, in the pieces vector or hash vec is not unique. The pieces hash vec exists alongside an array of info keys, so which means that we could potentially just have a single list of piece hashes for all of the pieces. So what are we?
Well, the problem. Well, okay, so we already had this talk like 2 weeks ago. we already talked about this 2 weeks ago, but we use the length you see in the info keys. See how there's a length field in the single, and then in the info file there's a length field where we have the length of the file.
Yeah.
Use that because files are listed in order, so that means that the first file in the file list would correspond to the first X amount of pieces, and the second file in the file list will correspond to the second X amount of pieces. So they're in order, in identical order to the piece vec. We use the length to determine the bounds of each file. So the length of that file would determine the bounds of what pieces it intersects with, and like what pieces.
Oh, right.
Yeah.
Okay.
Yeah. Remember now?
Yeah. Okay. So that should be fine. So our pre-start just needs to go through. What are we doing in our pre-start again? In pre-start function.
What do you say?
What are we
Pre-start
doing?
is supposed to write null bytes to all the files it has.
Oh, okay. All right. Did you say that you found a function for writing null bytes?
Yeah.
Okay.
It's unsafe though, by the way.
Oh, nice. Can you send that to me?
Yeah.
In the roleplay
Don't ask
channel.
me what it does. I found it on Stack Overflow.
Okay.
And this only works on Linux.
Oh, nice. Oh yeah. You said.
Yeah, so this only works on Linux. If
So
you use libc directly.
oh God. Oh, that's terrifying. Oh,
Yeah.
hold on. Let me show chat this. This is. Oh God, that's terrifying. Oh. Oh. Oh, that's not. Oh, I don't want to do that, man. I mean, I know we have to, but like, I don't want to do that.
No,
Huh.
we don't have to. It's just like the only zero cost way that we can do this, but it's
Yeah.
specific to Linux. And then we can also pipe it through /dev/null, or /dev/0, and that works too. And then on Windows, we can just write the bytes as chunks.
Yeah. Wait. Hold on.
Be inefficient, but it's fine.
Are you sure that we can't just use the seek trait for this? I understand why we need to allocate bytes for this, but are you sure we can't just use the seek trait and just not have to allocate bytes?
So the problem is, let's say we're trying to allocate bytes. Let's say we want to allocate, let's say, bytes 20 to 40, right?
Mhm.
And bytes 0 to 19 don't exist yet, right? So let's say we allocate those bytes and we write it to the file system. How does how does the file system know that those are supposed to be the 20 to 40 bytes instead of 0 to 0 to 20?
No,
How does it know that?
I know, I
There's
get
nothing
that.
there.
I get that, but how? Oh, because seek only provides a cursor that can move within a stream of pre-existing bytes. Okay, so
Yeah.
okay. I swear there's a better way to do this. I just forget.
Well, I mean, technically speaking, since we're writing the files sequentially, writing the pieces sequentially, so in order, we can technically do it with seek.
I mean,
without writing it, but that would make it's not that much hassle right now, and it would make creating receiving pieces non-sequentially, like the rarest piece, a lot easier later on. So I don't see why we wouldn't do this.
yeah. Okay.
It just means we would have to write a lot more OS specific code.
Yeah.
Doesn't sound that bad.
Yeah. Okay. All right. Hold on. Let me. I don't. If we have to do it using libc, I mean, we'll live, but I'd rather not. Just because that's. Yeah.
Well, we can use /dev/0, but that's less efficient. And then the least efficient. So there's three methods. You have the Linux specific libc unsafe allocation, which does basically writes it directly. It writes it directly using the disk itself, so it doesn't use the memory at all. And then you have /dev/0, which chunks it into memory by default, and it's a little bit more efficient since we don't have to create the zeros. Then we have the least efficient way, which is just chunking it ourselves and just sending raw bytes.
Yeah, that's not great.
Which would increase the memory usage by a lot, but we're probably only going to do that for Windows because it's the only one without /dev/0. So
okay.
Maybe, yes.
Huh?
It's not that hard to code either. Like, that's not anything that's like insanely taxing or
No.
mentally. It's not hard to code at all.
Yeah.
Just writing zeros to a file.
Yeah.
Specified length is not that hard.
Hold on, let me look at Fallocate.
Let me check what else is in infodix.
So
we have the info file.
I don't know why it has to be. I mean, it's C, so obviously it's unsafe because it's goddamn C. But I don't know why it is unsafe. Because it should.
Because we're doing things outside of the We're doing things outside of Rust that Rust can't control, basically. Like,
okay.
this isn't part of Rust at all. That we're using external binaries that have nothing to do and have not been checked by Rust. So that's why
Okay.
it's unsafe.
Okay.
Because Rust has no clue what we're doing. We're just like the Rust analyzer or the compile checker has no idea what's going on.
Yeah.
Because we're using things that are external to Rust.
Mhm.
So that's why it's unsafe. Because
Okay.
yeah,
Okay.
again, there's no idea what's going on.
Yeah, that seems okay. Okay, let me look at like the allocate man page. Wait, why do we need dev zero again? Because if we can just allocate with
Mac
huh?
OS support.
No, but where are we using dev zero in the code that you sent?
We no, that's Linux specific. So that code I just sent you will only work on Linux.
Okay, but where do we use dev zero?
No, that code doesn't use dev0 because it just bypasses that completely. And does some weird file system stuff where it just generates zeros using the SSD itself.
Okay.
And just writes it.
Okay.
So it doesn't use dev0. It just does some weird OS level stuff that's specific to Linux.
Okay. Alright, I guess that seems.
I wonder if there's a way we can do this with the shell. Maybe we can spawn like you spawn a child process to do this.
What do you mean?
It wouldn't. Like just use bash.
Why would we use bash, dude?
Because it's better at this than we are.
No, it is fair, but like, it seems not wise. Yeah, and
Whoa. What happened?
no, nothing. Okay, the other thing. Okay, so we allocate this, and then oh, right, because okay, yes, this makes sense to me. So here, this will probably need to be changed, but it would look something like for file in info dict dot. Do we not, is info keys not public, and is there no publicly accessible method to get the info keys?
I can change that.
No, I can just change it to pub file. Yeah,
I got you.
thanks. And pub file, so if it's a single file, MB5 some of the files, so okay, so if it's a single file, it should be match. Well, it doesn't really matter. It should match file. Why is that so mad at me? What? Oh. Info keys single does something, and then if it's a multi-file, we need to use something else. So, multi-files, blah blah blah. Okay, is that not iterable? God damn it! Hate my life. Dot. Oh what? Oh no! Can we not iterate over that? What? Wait. Oh no! I'm actually don't look at what I'm doing. Don't look at what I'm doing. Don't look at what I'm doing. That was the most embarrassing moment in like my entire life. I swear.
What are we doing, Oscar?
Don't. You didn't see that, right? You didn't see that, right?
Yeah, happens to the best of us. Yeah.
Okay. I just want to clarify. You didn't see that.
Type.
Okay. Good talk. Okay. Okay. File. Create. Info dict. We'll just do dot name.
Yep.
Let file. I don't know what FG is. I have to look at this.
No. We're only doing this on Linux.
Oh, right. So, okay. How do I do the target macro?
Just do config target OS equals, and then
It's me Unix or Linux?
So this would be Linux.
Okay. Beautiful.
This would only be for Linux, and then we'll have. Oh. Did we do Unix?
Let me.
Well, because we also want to support FreeBSD. That's another thing. Lose my NAS, won't be able to run this.
That's Unix based though too, right?
No.
Wait. Am I crazy? What? FreeBSD isn't Unix based? Oh, right. Because it's like, oh, right. No. It's
It's own thing.
Yeah. No. Yeah. My bad.
A lot of. Yeah, they have a lot of similarities with Linux, but no, it's not.
Yeah. No. It's Unix like, but it's not Unix based.
Yeah.
Okay. Well.
So. So we could probably.
Conditional compilation there. Target OS. Okay, yeah, so there's a few. Oh god. Yeah, there's quite a few options. Let me send this to you. There. There's quite a few options with how we could do this and what we would go for. But yeah, that might make our lives a little bit harder. Okay, so iOS, we don't care about that. Android, we don't need to worry about that for now. Dragonfly, I'm gonna be honest, I've never heard of that. I'm gonna be.
We're gonna do target family.
Oh, that's nice. Oh, that's so nice. Okay, yeah, target family. Is hold on. Target family Unix is.
We can do like this. Do if use a macro like this. That works.
What's the difference between you doing that and just?
Because now we can have an else. Now we can have conditional.
Or,
Other one didn't have an else.
Yeah, but we can also just do like multiple.
Yeah, but that's less specific. That's more specific, and we don't want this to be that specific because it's pretty sure we can have multiple target. I'm pretty sure there's going to be target families that aren't Unix or Windows, so it's better to be less specific here if we don't need to. So we can allow this to build on different OSs.
Okay.
It's not going to hurt us to allow it to build on, say, freaking Android or iOS.
Yeah.
It's not going to hurt us.
So
So we can do an else.
Yeah, but wait, no, but if it's not gonna work, if it's not gonna.
No, it will work. It will work.
Oh,
So we have
right.
Remember, there's 2 different methods where we have that will work on all different OSs.
Yeah, that very generic.
So this
but
actually
slow
should
method.
be. Yeah. So this actually should be target if target equals. What was our original thing? Was it before?
Target OS. Linux.
Oh great! I just deleted everything. Okay, whatever.
Okay.
Target OS. So we're gonna see this. F. Okay. And then else if big target family was Unix, and then else. This is if we don't know what it is. It could be Android, it could be iOS. We don't know.
Yeah. Wait, will libc not work on Unix? Cause there should be.
No, that line of the code I sent you, it's like Linux specific. It only works on Linux.
Oh shit. Okay.
It doesn't work on Unix systems.
Okay.
I think the as raw FD thing just doesn't work outside of Linux or something.
Okay.
So we should be using Tokio FS over.
Oh. We're not. Okay. There. I should get you. All right. Select file, and then fd equals file dot as. Oh, yeah, we gotta wait. Because you can unwrap that, but we want to question mark that. I need a result on this.
Actually, yeah, it's actually, yeah. Doesn't need to return anything.
Yeah. I think we need to include as FD. I don't know if there's a Tokio implementation of that.
Hold on. Why is my thingy going away?
There we go. Oh boy, something's mad. Okay. Oh. Let's throw something. There. Temporary. Oh, I need to change the signature.
Should probably move this to its own function. Hold on.
Oh, okay, yeah, I see what you're saying.
File piece manager. And create a file. Okay, and then all we would need is the length. Right?
Oh, okay. Yeah. I see what you're doing. So
Length.
you need the file name too.
Name. Actually, this would be whatever. It's just do name, string, length, size, and then path, option, path, buff.
Wait,
That's fine.
as FD size. This is where it's gonna get fun. libc. Do we need like a? Hold on. Let's put the raw file descriptor. What is a file descriptor? Oh, okay. This process is a unique identifier for file or other I/O resource such as a pipe or network socket. A network socket, not sausage. API, each thing's process should have 3 standard file descriptor. Process unique. Okay, I guess that kind of makes sense. Index into a process file for tabling the kernel that in turn indexes into a system-wide table of files opened by all processes called the file table. Oh, that's been open. Oh, okay. I think I see what we're getting at there. Okay. Cool. Cool, dude. Cool. Why is enum takes 2 generic arguments that 1 generic argument was applied? What? Do you just want it to be like none? Hold on.
Okay. We have to figure out how to do this parallel.
Hold on. Why do I need to have 2 generics for the result in pre-start? Am I using a different result or something? Oh, we also need to be using anyhow result, don't we?
Yep.
Oh, my bad. Is it happy now? Okay, great.
That's just this function printing something wrong, I think. Oh wait, expected U size. U64. No. U size.
Message types, expected enum.
Actually, you don't even need this. You don't need this. This. Speed. Paths. Actually, I
So
think this itself. Oh, here, it actually store base path for this here. So what we would do is do we want to concatenate? Yes, we do. Base
here,
path show. Okay, and then here we do self.
should be
self,
find that
self,
path.
bam. Okay, so now what's yeah, so file.path is actually just a vec of strings. We need to convert that into a path buff, and then we just go path buff.
What does that want? You could like as path buff or some shit? Huh? What do you mean? How do you mean? Create empty file, path and length. Oh. Oh, right. I think you should remove the none. For some reason, have that now. Okay, yes, do all that.
Get string found. Wait, is this? Yeah, this needs a path buff. There. Okay, this needs this. And then like this. Okay, and then this.
I need to be dot into.
No, we need to do path buff.
You can just do an impl or whatever it is, like impl or dyn path buff, right? And then instead of having to convert that directly from
No, it'll be fine.
all right.
That's fine.
ND5 some unused. I guess yeah, we're not really ever gonna use that in pre-start. Oh, right. Do I just like put that there? There we go. Now you're happy.
Yep.
Okay, we gotta wait, and then okay, what is this map about? Because it. No, I should work fine, because we shouldn't need that.
No, because you need to return the file.
Oh.
But we actually shouldn't even return this.
Yeah, I was
I
gonna
think
say.
we shouldn't return anything.
No, yeah, there's no reason, because as long as opening the file isn't taxing, which I don't think it should be. Yeah, it should be fine.
Wait, what? Why is this getting angry? Expected enum STD results. Anyhow, error found unit type.
It's just
But we're returning okay. Oh, it's because no error.
no. I was gonna say like it should be that, right?
There. That fixes it. Why is this?
What?
Oh, there you go. Okay, we're good.
Wait,
We're good.
what'd you do? What?
All the branches return okay anyway. So yeah, it just works now.
Yeah. Yeah, but what'd you do?
What do you mean?
What'd you do to fix that?
You just had an okay at the end. I just deleted it. And removed a semicolon.
Oh. Okay.
Yeah.
If I said identical blocks, you're gonna be fine. Then what's this? Okay, okay, same as this. Okay, so create empty file. Okay, so then this needs to be what you sent to me. So the libc stuff. So. Oh no, wrong thing. 5. Oh, okay. Just oh my god.
I'll be pasted, man.
Yeah, no, you're right. But do we import? Hold on. To remove some of this. Yeah, now where do we import? We don't have to cargo add that, do we? Hold on.
No.
Libc.
Probably not.
Yeah, I was gonna say, Jesus. Oh, wait, we might have to. Hold on, what? There's no way, right? There's no way it's like a separate. I think we have to. Yeah, we do. God damn it.
All right, we're not doing it then. We're
Da-
just gonna go with the Unix method.
Bro,
I'm not adding the libc package, bro.
Ew, it's libc. It's like. Hold on. Let me think of like a funny analogy. It's like. God, I'm really not that funny, and I can't think of anything good. No, just
Yeah,
it's
we know,
libc.
it's okay.
Man, shut up. No, but it's libc, bro. It's libc. Dude, it has like. Hold on. Let me look at the dependencies. There's no way it has more than like a single dependency, if that. How do I see dependencies?
Yeah, but like that's just. Yeah, I already see it has only one dependency.
Right, we have 500. This
But I
is
just
like.
don't think it's worth it. I just don't think it's worth it.
You're no fun, dude. You're no fun. Okay, fine.
This guy just wants to talk about C code.
I love C so much, dude. Oh my god, I want to get hired as C dev. I mean, I really don't. Actually, dude, honestly, dude.
Have fun having 100 lines just to parse a JSON file.
Yeah, no, that's actually surreal. But like, dude.
Well, in
you're
JavaScript, it's just one file. I mean,
so,
just one line. And
so fun to.
Rust,
Oh,
about well, depending on how big the JSON file is, it's like
if there are any
3 lines.
startups looking in chat right now, and those startups really want their software written in C, call me.
why would they do that?
I don't
Like,
know. I don't know. Because
Why?
it's some random dude on the internet.
Just use Rust,
But it's C.
superior language. Okay, wait, I'm rage baiting. I'm rage
Yeah.
baiting.
Uh-huh.
Okay, I don't.
hello,
Yeah, I'm not doing that.
evangelist.
If it requires libc, I'm not doing it.
Bro, dude, it's libc. It's like iconic, dude. It's libc.
I'm not using libc. I don't care. I'm not using libc.
Okay, okay. We'll just remove this then. Okay.
Yeah, let's remove that. Yep.
Let me just hold on. Okay, go
make
ahead.
your frown faces. Okay. Very necessary. Let me just like.
Hey!
Anyways.
God damn it. All right.
Yoink. Oh,
Okay, so yeah. So what was the other way that you wanted to just like chunk it? You said. How?
yeah, we can create a raw. Here, I have a code for this. Hold on.
Oh God. Well, I mean, we could just create like. Yeah, I don't know how you want to do this. Up to you, bro. Up to you. Up to
Okay,
you, bro.
so it's literally just this.
You just create like a blank file. Let me see what you got. Oh my God. This cannot. There has to be a better way. There's no, this cannot be efficient. This cannot be efficient.
What?
No, there's no way. There's no way. This cannot. What? There's no. Oh, this is completely AI. God damn, are you using T3 for this?
Oh.
Why is there?
Is this AI? Huh?
Why is there a
How is this
comment?
AI generated?
Why is there a comment on every single line?
Stack Overflow.
I'm just gonna check something real quick. Let me see if I can just like.
Already checking.
God damn it! Hold on.
Dude, I'm checking.
Hold on. To pad file stack overflow. That's a string, not a file. No, dude, no, dude. That is dude. No, that's absolutely, dude. Oh my God. No, dude. Okay, so you're suggesting that we copy potentially gigabytes for every file the user wants.
No. No. Look. What? No. Do you know what the copy does?
Hold on, let me look, because apparently copies all the bytes from one object to another.
Yeah, it's a stream though, so you know the bytes aren't the bytes aren't loaded immediately.
Right, but
As they come, they're written. So like no, so as what's happening is the moment the bytes are received, they're immediately written and ownership is sent out to the output. So let's say we read a byte here. The ownership of that byte is sent to this right here immediately, and that gets written to the disk, and then that gets dropped off. So it's writing 1 byte at a time, basically.
Hold on. So, okay, so you're saying that we're not copying everything at once? That as we write
If we read, we're writing at the same time.
So you're saying as we write to the file?
As we read from dev0, we're writing too.
Okay, but we're still copying.
No, it takes we're 1 byte at a time, Oscar. That's what you're not understanding. We're never gonna have gigabytes of stuff in our memory at a time.
I'm not saying I'm not making any argument towards memory. I know that we're doing this one at a time. I'm saying that we're copying potentially gigabytes.
Yeah.
Doesn't sound too efficient, does it?
What? Okay, are you talking about memory efficiency?
I'm talking about the efficiency of copying a gigabyte.
It's not copying. No, it's like sending the bytes directly to a reader to a writer.
But we're still writing a bunch of bytes.
We have to. Yeah, there's no other way to do. You can't just magically rub on a genie thing.
No, there has to be. No.
and have bytes just pop up on your machine. That's not how that works. You have to write it yourself.
Okay, hold on.
That's what the libc thing was for. That's what that does.
But then
that doesn't use any. That doesn't require us to write the bytes.
Okay, I guess I don't even know. Maybe. All right. Okay. I guess. Okay. Is there no? There has to be a better way.
Oh,
No. Okay, but why are we copying from dev0?
Dev0 has 0 bytes. We don't have. That means that we don't have to create the null bytes and store them in memory.
Right, but why don't we just for x and tons of
because
bytes.
It's less okay.
Like,
so you want to create an individual writer for each byte?
why not?
It's less efficient than what this is doing.
How so?
This doesn't create a new writer per byte, Oscar.
Huh?
Might be time to end stream chat.
Oh my god, dude.
I think he's clocking out.
Dude. Okay, no. I mean, hold on.
Oh my god. Might be time to end stream chat.
No, dude. Okay. Yeah, maybe I am gonna take a break for tonight because I do actually need to get my sleep schedule back on track.
Yeah.
Okay. Yeah. You know what?
I mean, it is Labor Day, so I mean tomorrow, so like we can.
Yeah. But I still have
nothing
stuff
to
to
do
do tomorrow. I have to start looking for goddamn internships. Okay. Yeah.
Someone just said hello. Hi.
Someone said hello the moment I leave. Oh,
Hi.
oh, oh, oh. That was like a long time ago. I already said hello back. Thankfully I saw that. Okay, yeah. Well,
Hi. Hello.
I'm gonna
Hello.
call it tonight.
Yeah.
I'll hopefully be back like tomorrow night if I have the time. Hopefully. Yeah.
I'll be here.
Peace.